All right, thanks, Gary. And we'll go back and probably talk a little bit about a little more background on some of the tables, because I think the percent removal for a specific BMP is a little bit confusing because it's really site-specific and the amount of slope you have and things like that. So there are some things with that. And you might have noticed, I'm not sure if it was noted at the bottom, that that's for less than a 9% slope, that table is. So if the slope is over 9%, then you have to use, if you want to use alternative methods, then you have to use a model, because that, once the slope gets that large, the tables are not applicable anymore. So when you're trying to create a buffer and you want to use some of these alternative methods, there's a number of different models, and these are just some examples. And if you guys have something else that you like to use, there's probably some other ones as well. But Carrie mentioned the revised universal soil loss equation. There's a series of those models. And what I actually used to develop these tables is Russell II, which has a nice Windows interface, and it's relatively easy to use. WEP is a USDA model. The sediment series is a downloadable model. It's a little bit older model. It's DOS based. Was developed by Bill Barfield, who's an emeritus faculty from OSU, and he actually developed that when he was on the faculty at the University of Kentucky. And then SedPro is actually a model that's proprietary, developed by Wolpert Incorporated by Dr. Barfield when he retired and he started working for those. But that's actually Windows-based, and that's really nice to use. I think it's probably about state of the art for this type of modeling. And then also SedCAD, which is from Civil Software Design. That's also a proprietary model. That has some GIS type of capabilities into it. A lot of the equations and those type of things that are used by SedCAD are based off the ones that were used in Sediment. So any of those types of models will be useful, and depending on how complex your site is, different ones will probably have different uses for you. So revised universal soil loss equation, this is probably a bad time of the day to have an equation up on the screen, but basically you're calculating erosion per unit area with the revised universal soil loss equation. It's based on a number of different things that when you get into Russell II, that we'll show here on a screenshot in a little bit. Most of this is actually calculated for you, but I just wanted to talk a little bit about what's inside and what it's based on. So you have this K factor, that's your soil erodibility. So that's how easily that soil will erode. You have a slope and length factor. So obviously how far the water goes along the slope and the degree of the slope will make a big difference on how easily those particles are dislodged. And then C is your degree of soil cover, so vegetation and those types of things definitely make a big difference on that. And then your supporting practices, which is our erosion control practices that go into there. And erosivity is based also a lot on climate. That's basically precipitation and how intense the rainfall is. So this is just some relative numbers, but you can see there Las Vegas at the lowest, Tulsa up there around 260. Oklahoma City isn't too much different than that. It's actually a little bit higher, I think, about 280, and Dallas 275. So that erosivity factor plays into it, and that's why you have to put your location into the model. Texture obviously makes a big difference, and Joe talked about this quite a bit. So your clay is a much smaller particle, and it's resistant to detachment. Your sand obviously is easily detached, but it doesn't move very far because it's bigger and it settles out. Your silt loam, that will detach moderately easily and moderately to high movement in the runoff. So that has a higher erodibility factor on that. And then your silt has the highest erodibility factor because it's relatively small, it's easily transported in the runoff, and also easily detached. Length slope factor, once again, is based upon your topography, that type of thing. That's pretty self-explanatory. But one thing that's important to note when you're trying to model this is that it's based upon a simple slope. So if you have a complex slope where it goes from one slope to the next, you're going to want to model it in pieces. And it's relatively easy to do that with the Windows interface. And especially when you get to convex and concave type of a shape, Russell might not be the best thing to use for that type of a system. Let's see here, attachment proportion to the slope. So as you have a higher slope here, obviously you're going to get higher detachment as the slope increases, and most of these things are pretty common sense, but all of these things are put into the model. And then we have our cover management and supporting management systems, are things that's based upon what kind of vegetation you have, and you also have, it's based, also can be utilized in agricultural areas. So if you have crops or conservation tillage or that type of thing, that can be implemented into this. Obviously for the construction, that's not going to make a big difference, but as you get more vegetation, you have an increasing amount of random roughness, water slows down, and you have more of a chance for those particles to settle out. And then there's a lot of different things that can be used for what they call supporting practices, or basically our BMPs, including silt fence, wattles, check dams, contouring, strip systems such as our buffer strips or filter strips, different types of barriers that you can put in there, also with terraces and diversions and even impoundments. All of those things can be modeled with this type of thing. So you can get into a relatively complex system for controlling your sediment on your site, and makes it not too difficult to model. So here's an example, and see if I can find the laser right here. So this is Russell 2 right here, and this is just a very basic system. You have a certain amount of slope, and this is what it shows on the screen. So all of those different factors that I mentioned, really all of these are kind of behind the scenes on here, but we just put in here a 100-foot section with this one has a 6-degree slope, and it puts it up there, and then you go into here and you can get your location, soil, topography, management, contouring, all the different things that go into modeling your particular area. You can go in there and put it in. So right here in Oklahoma, they have Oklahoma County and Tulsa, and once again, that's based upon your precipitation in the area. So that's where that is, and then you can put your different soils in there. They have a lot of generic soils. They don't necessarily have all the soil series from Oklahoma, but they have a lot of generic. So if you know kind of you have a silt loam or a sand or whatever, you can put that right into your eroded area. And then she mentioned on the tables that there's a cut and fill. So obviously if something's a cut and you have parent soil on there, it has a lot different cohesiveness on there than if it's a fill and you're putting it in there and maybe compacting it some, but it's probably going to erode a lot easier. So whether or not you have cut or fill on your construction site is going to make a big difference on how the probability that particle is going to come off of it. And then you can go and implement on the end of it your different best management practices here. So they have silt fence, and you can actually model it how well you think it's going to work. They have full retardants or half retardants, but obviously for modeling purposes, if you're trying to implement then that you're going to assume that you're maintaining it correctly, and then it's going to work. So they also have fiber rolls. That's what they call a wattle, compost socks, gravel bags, mulch berms, permeable barriers, a lot of different BMPs that you can implement that into there. So then what I went and did here is I just modeled a section, a 50-foot section of a site here, a construction site, and then we have our filter strip down here, and we have a soil loss here of 39 tons per acre per year that it calculates up. And then sediment delivery after I put everything in there was 2.5 tons per acre per year. So you're removing 94%. You'll notice on those tables that it has 90% as the max for everything. We copied the procedure for this from the EPA construction general permit, and what they did is if it was over 90%, they just put it at 90% because of the uncertainties associated with that. And that way, if you put two different BMPs together and you're combining that, you're only really reaching that 90% because something's probably going to remove 99.5% of it, but they're not going to put 99% in that table. They just put 90% in there. So that's why there is 192, and that was just an oversight that we missed that when we put it in there, but really it should be 90 on everything. So really it's pretty easy. It's just a bunch of drop-down menus and you're describing your system. And obviously when you get more and more complex on your construction site, it's not quite that simple, but it's Russell 2 is really fairly easy. When I was going through this process, I called up the folks at the USDA for support, and they're really helpful helping you out. And some of these other models that are proprietary, I've worked with some of those folks, and they're usually pretty good as well. And as you start getting different systems, when you're looking at these percentages of removal, you know, if you have a 10-foot construction area that's really long and it has a buffer along the whole length, you know, if it's only 10 foot wide and it's going into a 100-foot buffer, it's going to remove everything. But if you have 10,000 feet coming onto a 100-foot buffer, it's not going to remove the same percentage. So those percentages are based upon some assumed lengths of your site and that types of thing. So if you start to get irregular shapes, or you want to check out and see if there's different ways that you can do it, some of these models can be really useful. The tables are something that you can use, and they're a nice guide, but it doesn't hurt to try to model it a little bit and see if there's other things that you can do that would be equivalent. So that's all I had about the models. Carrie, did you have anything else to add to that? Okay.
Well, I've got a question. Okay, as I understand it, then if you want to use an alternative, you go to the tables, but if the slope is greater than 9% on the site, then you have to model.
Because the tables were based on a 9% slope, so they'll be conservative for any slope less than that. But if it's greater than 9%, then the tables will not be applicable.
So you have to model at that point?
Yes.
Okay. Do you feel like those models are something that the average person could use? Because they seem pretty, I do modeling for water quality, and I know I wouldn't turn that over to somebody that didn't know what they were doing. So,
are there any landscape architects in the room today? Okay. Well, I had a landscape architect do this modeling for me, a landscape architect master's student. So, and she had never done this type of modeling before, and she figured it out, you know, within a day. So it's the Windows based of Russell 2 is fairly easy to use, and it's just downloadable on the web, and they have some nice instructions on how to use it and that type of thing on the web.
You're free to use whatever model you want. Is that correct then? Mm-hmm. Okay. Are there any other questions? Oh, yeah.
Okay, I just want, hello, this might be
Carrie,
for
we might
Carrie.
have a question for you.
Okay, it's working now, maybe. As far as, I just want to get this straight. If the 50-foot buffer, even though you have a 50-foot buffer in place, the perimeter controls are still being required. So a perimeter control like a silt fence, which based on our slopes appears a 90% reduction that you're going to have in addition to the 50-foot buffer. It just seems like you're...
I can explain how I modeled it.
Please.
You can tell me if... Okay. But basically, this is like insurance. So when we modeled it without the silt fence in there, but it's really like insurance. So the modeling of it that I did and what's in the table is not including those perimeter controls. You're assuming there's no controls on what's coming off of the construction site. But in practicality, you're going to have those controls, but you're assuming all those other ones failed, and then this is your insurance. Is that a good way to describe it?
Yeah, that's a good way to describe it. And we've We've started to have this discussion as far as how that's going to work, and my discussion with permitting is it needs to go through the perimeter control before it goes into the buffer. So you may have wattle, silt fence, whatever buffer you can provide, and then it will go into the creek or something to that effect.
Was there any interpolation, though, allowed if you have 30 feet buffer? I mean, are you allowing any interpolation, or are you assuming? I'm asking the hard questions.
So if you have a 30-foot buffer and they require a 50, then you
Right.
have to get alternative controls to get that extra 20 foot.
Yeah.
Right, so it's just the 20 foot you're looking for at that point, not
Yes.
the full 42 or whatever.
Yes.
I have a procedural question, and that has to do with, when you do these calculations, does that become a part of the SWP3? And is that submitted to DEQ, or is this something that has to be done? How procedurally are we going to handle that?
That's a good question. My understanding from reading the permit is if you use an alternative calculation method, you need to include all of that information in your SWP3. That's the way the permit reads.
And then DEQ will go through an evaluation process.
You will have to talk to Karen on that, but I assume so.
All right?
The 9% slope you mentioned earlier, is that like the steepest slope you get, or the average slope of the what?
On the EPA construction general permit that we worked off of as part of the stakeholder group, and they had the original version of this for several cities across the U.S., they used the 9% as their criteria, so that's what we went with. And to be honest with you, I don't know the background of how that 9% came about. But we modeled it as a 9% and then assumed everything else from that number would be a conservative estimate for.
Well, what I'm saying, it wouldn't be all 9%, you know. Is it the steepest slope of that area would be what you consider to be 9%, or the average of all the slopes?
Sorry, I misunderstood your question. It's the average slope.
Thank you.
Terry, so that I understand, I'm a little confused. If you have a waters of the state crossing your site and you're going to build a shopping center, and you're disturbing around the site, you're going to leave your 50-foot buffer, so nobody's going to touch that. You're still requiring the construction, the best management practices to have silt fencing that whole creek that crosses the site?
You need to provide perimeter control as well. That's part of your regular requirements of your permit, is to provide perimeter control for your site. If it's needed in that location, then you have to provide it in addition to the buffer.
Because your waters will be within your site.
Right.
So that wouldn't constitute the perimeter of it. That's part of it. So I was thinking that the 50-foot is what you were using to prevent any pollutants from entering that water stream there.
What are you saying? Coming through the site, yeah. Well, yeah, you'd have to have it on both sides, because the stream itself is not part of your development. So that's what you have to protect. So you would have to have that you'd have to have some sort of perimeter control there.
Okay.
I wonder if some of the confusion is that people are looking at the buffer zone as a BMP and not as, they're thinking of it as that's going to filter out their sediment before it gets to the creek. And what we're saying is that's a riparian area that's not going to be touched. And so we don't want anything going to that creek. Is that
Yes.
That's the gist of it, right?
Yeah, that's a good way to look at it. You don't treat the buffer zone as a BMP. It's required to be there to protect the stream, to protect the waterway. So your BMPs have to occur outside of that buffer zone. Yes, it will filter out sediments, but we want to be able to protect that area from receiving the sediments. It shouldn't be your last line of defense. There should be something else out there. I think that's a good way to describe it, Jeremy. Thank you.
Hello? There we go. All right. I don't want to assume anything, but if somebody has a site that would have required a 50-foot buffer before the new permit, the construction general permit came out, and then obviously everybody has to reapply, how closely is that going to be looked at? I mean, when they reapply, they're going to have to meet the criteria of the new permit, correct?
Right, and I think that's something we're going to have to look at on a case-by-case basis as they come in.
If you're reapplying, you're resubmitting your
Yeah.
SWP3.
Yeah, your SWP3 that you resubmit should meet the requirements of the new
Right.
OKR10. If it's an existing site, we're going to have to, I think we really just are going to have to take that on a case-by-case basis and see what is the current condition of the site, what's, you know,
Renewals that are in a sensitive watershed have to have their SWP3 submitted.
Well, and they may not be in a
Right.
sensitive watershed,
No, if they're-
obviously. There may be some places, as we've already discussed, that aren't necessarily discharging to waters of, waters of concern, but they've got a creek running through
yeah,
their
right.
site.
You're talking about any site in this area or
That's
anywhere else
exactly
across
right.
the state that's not in an ORW or an ARC.
And they may or may not have disclosed that in the documents that they provide to the DEQ or to anyone else. Are we going to also assume that an engineer would be required to do some of the work related to that buffer or require a stamp with the pollution prevention plan that's submitted?
Yeah, if it's a practice of engineering, then it's going to require P. Yeah, if the landscape architect did it, we're going to leave that up to you.
Oh, we don't want to get into Archie and an engineer discussion. The other thing I was going to ask is that I noticed earlier there was some discussion about sediment basins. My understanding is sediment basins isn't something you're not going to allow just anybody to develop a sediment basin and submit it with a pollution prevention plan. That would be something that would require an engineer as well, wouldn't it?
It depends. As Joe went through in his presentation, if you provide the, 36?
Yeah, but how do you make
3,600
that?
cubic.
You're going to allow any layman to make that calculation on their own?
We have.
Okay.
It's the if design part of it for the 2-year, 24-hour storm event that it's more on the side of practice of engineering.
Thank you.
If the, if the stream is running through the property you're developing, then you're not required to buffer?
Where am I looking? Yes, there you are. Okay, sorry. Okay, I'm sorry, go ahead.
If the stream is running through the property you're developing, then you're not required to buffer.
If it's running through your property, you are required to provide the buffer. If you can't provide the buffer, then you have to provide alternative sediment control, I think is where we're at with that. Or if it's running adjacent to your site, you'll have to, if it's running through, you're going to have to look at both sides of the stream. If it's running adjacent, you just look at one side. Did you get, yeah.
If we're making a crossing, then what do we do?
If you have a crossing, those crossings are going to be the ones that we're going to allow you to make the crossing. That's the part of that's exempt from the buffer requirement.
What she's saying is you have a 404 permit.
Right, that's part of it. No, and it says water crossings, and I don't know that that necessarily has to have a 404 permit, but I'm not an expert on 404 permitting,
Permission.
so. Well, yeah, where is Elena? She was here. I don't see her.
That does need to be clarified because not every bridge crossing is going to require a 404 permit. So I guess my question is it a water crossing only? Is it if the purpose of the project is a water crossing and you can minimize the disturbance to the maximum extent practicable, is that sufficient to justify the buffer zone? Or do you have to have a 404 permit authorization?
So you don't get a 404 permit for every
If you're not
bridge that
placing
you-
fill below the ordinary high water mark, you do not have to have a 404 permit,
Okay.
temporary or permanent.
What we're dealing with here is a lot of what-if questions, and we haven't really been through this procedure. As I said this morning, this is a part that was put into the permit. The ELG parts were not incorporated into the permit, but these non-ELG parts got into the permit. So I think there's going to have to be a protocol established. We're not the people that do that. We do enforcement. So the permit writers, which is Mark Dershwater and Karen, and they're recruiting someone else, are going to have to set up their protocols of how they're going to handle these and what the review criteria is going to be and so forth. When it gets to us, then we use enforcement discretion, and we're not going to enforce on this until there's some kind of a, until people understand what the requirements are, there's clarification of what the expectations are, and then at that point, then we can, start any proceedings that we have to do. This is a whole new addition to this, and I think we have to approach it on the basis of it could have been a lot worse with the ELGs and so forth. And questions you're asking, we don't really have the answers for at this time. We had to get the permit out, and now we'll have to establish the procedures for review of these things. It would seem to me, my background is in design and construction, and in contract law, there's always the doctrine of reasonableness. What's reasonable to expect people to do? You can't be unreasonable in what you expect. And I hope DEQ will adopt that same standard, that reasonableness standard. This is something we're going to have to work through with the regulated community. And it's not going to be an easy thing, but on the other hand, it shouldn't be that difficult either.
Thanks, Mike.
Are there any other questions? Got one more.
I have a question. Do we have a definition of a stream that we can look at? Because I wrote a buffer ordinance one time when I was in Tahlequah, and I got that question all the time. Is it an intermittent stream? Does it apply to that? Is it, we kind of need a solid definition of a stream.
Yeah, and it references perennial, ephemeral, intermittent in the permit, so it does cover that.
Yes. When are you going to mail out the notices to the current NOI permit holders, letting them know that they have to reapply?
We've already done that. Yeah, you should have received the invoice for October. Okay, and permit renewal should have gone out in September. And that was just for people who had coverage already under the old OKR 10. That's part of the reason why we're having this. We're hoping to clear up some things. I know it's going to, especially with the buffers, it's going to take longer to work through it. This is something we're going to have to learn as we go. And I can just give you what it says in the permit, and we'll have to work through the details as to how we implement it.
I've got one question from the jar over there. So do we have any more with this speaker?
I was wondering, it shows waters of the state in the permit, and I was wondering whether we are to use the blue line to identify the waters of the state, and then if it's a blue line, 50 or 100-foot buffer. If it's not, then it's not.
You know, I honestly don't know if that's the criteria that we're going to use on that. I'm going to have to ask Karen on that. So I think she's going to be here tomorrow. Let me corner her to see if we can figure that out.
The blue line that she's referring to is on the USGS 24,000 quadrangle map. If it's a line on there, sometimes it's purple, but it'll show a perennial or an intermittent stream. They don't show ephemeral streams. And It's been used for many years, is if it's on the 24,000 quadrangle map, or quad map as they say, then it's some kind of a regulatory application for permits and all. If it's not shown on the map, then you ignore it. I've heard that from Fish and Wildlife, Corps of Engineers, state agencies. I was at a site one time where on this side of the street there was the blue line, that side of the street it was missing. There was no difference in the stream channel. I think the guy that was drawing the line went to lunch and forgot about it. but nonetheless, it wasn't on the line, so I called the agencies and said, what do I do? And they say, ignore it. Our policy is the blue line, so that's what she's referring to. So the question is that still germane to these newer permit conditions, especially about buffers? Don't know. Other questions before I get to the last question of the day? Okay. The last question is, I feel like the amazing Karnak on Johnny Carson. And the answer is, a lot of the engineers have stopped doing SWP3, interesting, and are expecting the contractors to do them. Shouldn't this be done by an engineer?
It doesn't have to be done by an engineer unless it constitutes a practice of engineering. So if the contractors are developing it, there are templates out there. EPA has a template that you can use. There are other ways to do it other than having an engineer do it.
I think you would raise holy hell if you required SWP3s to be written by engineers. And I want to make, on a follow-up on that, just to be really clear, if you do the modeling, that is not an engineering practice. It must be done by a PE. Is that correct? A layperson could do the use, RSUL, whatever
You want to answer that
acronym model. How does that work?
Well, how that works is the practice of engineering is defined by the engineering board. It isn't defined by DEQ. And as you know, they now have investigators and stuff, and they discipline people and so forth. And so, you know, it's the board doesn't want people that aren't engineers to engage in the practice of engineering. That's why that wording is incorporated. We have a comment up there.
You can call the board and ask the board specifically about this activity, and they will tell you whether or not it is considered engineering.
Okay.
The answer was basically contact the board, the Oklahoma Society of Professional Engineers, right, OSPE board, and find out if they would consider the use of this model in the application for OKR 10 compliance to be an engineering practice that required a registered professional engineer to do. That's probably the best thing you can do.
This is something DEQ may want to do, or one of the municipalities, to go ahead and clear this up. Then that way you can present it at your next. But they have personnel that do this all the time.
I do want to say this. Again, think of this like a performance spec. You want something that performs a certain function to a certain degree of accuracy. Now, we don't care how you get there. That's up to the applicant. But if it involves the practice of engineering, then you need to use a registered engineer. Think of it in that way. There's different ways of getting to compliance. And so that's really the whole intent of this, is to get to compliance and to meet the requirements. The permittee can decide, but if practice of engineering is involved, then a registered engineer needs to do it.